Good morning all. Today I'm going to start on making this lithium iron phosphate 8-cell battery pack. Wire it up for use in both the bicycle, because these came out of the bicycle battery box, and also for use as a solar powered LiFePO 4 battery pack with crypto miner on the bench in my shed. Now, first thing I've noticed, if I look at the battery pack like that, is grooves, dovetails. So I want to try and take these end caps off and put them all the right way around so that at least the batteries are the same height. It's a pedantic thing, but I want to do it anyway. Another thing is these balance leads. I've used screws into a hole that I drilled in these, well, they're plated copper bus bars, and they just don't stay tight. And I was thinking, actually, I could probably solder that ring terminal down onto this bus bar if I can get enough heat on it. The Ryobi iron should do that. And then it would just be a bit more robust. You wouldn't have that extra connection point, and also you wouldn't have this possibility of it going loose. Soldering on there seems perfectly sensible. So let's take one of these off, unscrew it. I think part of the problem is that the thread doesn't, or peters out near the head of the screw, so when you tighten it right down, it's not as tight as it is in the middle of the screw thread, if you get what I mean. But I just fancy having a go at soldering that. So I want to get rid of this blue wire anyway, so I'm just going to clip bits off as I go, and it's all going to get replaced with this sort of stuff. It's all JSTs. I've bought various types, 9-pin. These are 7-pin, and I don't need 7-pin. I just bought them literally to pull the wires out in case I need them. Just got some 5-pin ones in. Oh, I can't find them. So let's undo the big bolts. Now these, the guidance, I mustn't touch across to one of these because they're probably, well, they're joined up by that link there. So the guidance was, there was a torque measurement that you're supposed to apply to these. I don't have a mini torque wrench, so I'm just applying what I think is the right torque. But I just want to get one of these off, get it down onto the bench on a piece of wood or something, and try soldering one of these tags on. So I've just got an attachment point for my balance lead. I'm now thinking, I'm not sure it's worth soldering a connector on here, a tag. Surely I could solder the balance lead straight onto here if I can get this hot enough. I'm just going to see if I can melt a bit of solder onto this piece of copper. Now I'm going to use the Ryobi iron for this because this gets viciously hot. 480 degrees this thing gets to. And it works better with these shards of brass or whatever they are for cleaning than a sponge, because it's so hot it just evaporates any water or any flux pretty much instantly. So a mechanical cleaning actually works better. So let's see if I can just place a blob down on there. Will it actually heat that up sufficiently to flow? Not yet. Not yet. I've got to get it warm. Still hasn't done it yet. Actually, I'm not sure this. Oh, it is up to temperature because my little light's on. No, it hasn't grabbed it yet. So it's simply a case of getting it hot enough that the metal will take. And it hasn't happened yet. I'll keep on it. Right, I couldn't get it to take, so you would have to get this extremely hot for that to flow. So I think I'll stick to a mechanical fastening, but rather than the screw, I think I'll put a nut and bolt through there. See if I can find some small nuts and bolts. Now I've got some nuts and bolts here, and they're ancient. They're actually 6BA and 2BA, which is an old British thread, but they look about right. They're quite short. What I really want also are these tags. There's a little tag in there, a soldered tag. That would be ideal really for attaching the balance wires. I might order some of those. Yeah, I quite like that arrangement where the bolt, and of course it's a slotted bolt because it's so ancient, with a nut, then a tag, and then another nut, so it's offset. I'll see whether I can solder onto the tag. I mean, that should be entirely possible. Right, iron's up to temperature. Let's clean it in the shavings. Yeah, I mean, that's fine. I can tin that because the heat doesn't get sucked away by that bolt. So that's a much better system. So I'm going to go for that. And if you think it sticks up a long way, well, not really any more so than the main bolt that screws into the battery. So I think that's all right. I was wondering if I could solder the bolt onto the tag, and I've got solder to flow onto the head of the bolt. It just won't flow on the tag, so I'm just wondering if I can scrape a bit of this coating off, because it's definitely copper underneath, and then get the bolt soldered on there, and then I only need the one nut because the bolt will become effectively a stud. I shall try it. Right, I've scratched some of this coating off to expose the copper. Let's see if I can solder that. Yes, I think that's taken now. So I've effectively got a bolt soldered to the copper bus bar, and that gives me a mounting point on the other side where I don't have to have a screwdriver on the bolt head. So I think that's the sort of thing that I want. That's still pretty hot. Right, these two are done. The bolts are soldered to the underside of these bus bars. They didn't quite reach actually, so I had to put a round file into the 6mm hole and file it outwards a little bit. They just seemed a little bit short, but they're done. I've drilled a couple of holes in there, and that's where I'm going to pass wires through so that my JST will end up, and here's a 5-way JST, on the top. Now I've marked the top there with a plus. Careful I don't short anything out. And I want the JST to just sort of emerge out from between two cells, so the wires will poke down there, and the JST will just sit here, because eventually it will wrap around there to this side and be connected here to a JST plug, which will go off to the 9-pin, which will make the whole pack. So let's do another one now. So I'm going to scratch the coating off this copper using my screwdriver that's got a broken end. I can't remember how I broke it now. It's a bit annoying, but if I keep doing this, it'll file it down and perhaps restore the end. So scrape that and scrape the other side like so. Okay, I'm going to solder another bolt into there, so switch the iron on. Can you see that flashing light? You can't, can you? There it is. Flashing light. Wait till the iron gets up to 480 degrees and then apply the solder. The bolt seems to take reasonably well, and the scratched copper takes reasonably well. Wait till that comes up to the top. Okay, that's hot. I think I'll just give it a wipe in the shards of brass, probably not brass because that was cheap, shavings. So let's get some heat on here now, and it just takes a while because it takes a while for the heat to build up on here, and all I'm doing is holding it on there and then just dabbing a bit more solder in periodically because all the flux burns off. I could apply flux to this, but it's in the solder, so I might as well just wait. And then when you solder the other side, of course, it's a lot easier because the metalwork is all warm. But that does take a while to take, and it's just because the temperature's not high enough. I think it might just be taking now. So yeah, certainly on the bolt it's taking. Right, we'll have a look. Oh yeah, that's taken on the copper plate as well. So just give it a little bit more. draw it away quickly. Let's spin it round, it's going to be hot. And have a go on the other side. That should take a lot more quickly because it's already hot. Can I see? Yeah, I think that's taking and flowing and running. This is the perfect time for this because it's ridiculously hot. It will get up to 480 degrees. Interestingly, I bought the Ryobi 20 volt iron. No, this is the Ryobi, sorry, I bought the Parkside one from Lidl, which is incredibly cheap, about £12 I think. This was 40 something, and I will do a comparison video. Right, that's soldered. Turn that off. Now these terminals, that's the positive, the one with the black goop is the negative. They're slightly different heights, so I'm taking to putting a washer on the black one because it's slightly further down, and then this goes this way. I've filed these out with the round file, and then my screws, my bolts, should go in there and do up without any stress. They were a bit stressed before, and I don't want to stress them, otherwise I'll end up stressing myself. Good, okay, that fits on there. I can just semi-tighten them with this, and then I'll torque them up with the wrench to, well, just what feels right really. So let's do that without shorting this to anything else. That feels pretty tight. Let's turn it around and do this one. Nice and tight. Okay, these are my final positive and negative terminals. Now I'm going to have to solder a bolt into that hole. Same process, scrape all the coating away, solder the bolt, and then I've got mounting points for my... I found a little spanner here. It's 5.5 and 5mm, even though this is a 6BA nut, and that comes undone, and my stud is soldered onto the underside of there, so that's not going anywhere. Right, excuse the background noise if you can hear the miner, but there's so much sun today I've had to put a miner on in here. All the shed miners are on. Now I've taped my balance lead onto here, but the way these are supplied, the black wire is not the most negative. So here it's actually the orange wire, and I don't really want to shuffle these around because it means bending the barbs twice, once down to get it out and once up to lock it back in again. So I'm just going to leave it, and I'll mark a little minus on there with a black Sharpie. But yeah, if I connect this into this tester, the most negative point is actually that orange wire. So the orange wire will go to the most negative point of this battery, which is there. So that's that connector there. And yeah, the colours are going to be virtually meaningless. Now I'm going to have a fair bit of difficulty getting the wires through these holes. So I'm going to use the 7-way connectors that I bought, if I can find them. Yes, they're here. These 7-way connectors. Just pull a couple of wires out, feed them through from the outside, join them up to these by just tack soldering one to the other, and then pull it through. Let's see how that goes. So the most negative is going to be that orange. So let's pass this black wire through the hole I made for that. Yes, it's going to be like that. Try and coax it up the top, which I have to want it up the top. No, I probably want it at the bottom, don't I, to attach onto these. So let's flip that round so that it goes the other way. Can I get it to come out? Not easily. Out you come. Oh, it's probably because it's fouling on these wires. Yeah, I've got to try and coax that up and out. I'll play with that. Right, with my normal soldering iron, I'm just going to tack these together. Will I need any fresh solder? Yes, I will. That's annoying. Bit of solder on there. Align these again. Tack them together. Oh, they don't really want to join together. I think that's joined together. And now I'm going to try and pull the orange through the little hole so it goes to where I want it to go, which is there. Let's give that a go. Well, they came apart because I've got a feeling these aren't tinned properly, or they're tinned with unleaded, and therefore my joint just wasn't good enough. So let's tin them again with leaded solder and try and get them to actually join together this time. Right, join together, you two, because you're mucking me about. Okay, they're joined together. See if they go through that hole. Good, so orange has gone through that hole. Now I'm going to get a solder tag, and I found a few of these solder tags, although I've just placed some more in my shopping basket with CPC, so that I've got 100 or so, because I think I don't really have enough of these. Solder tag on there. Now that's battery, oh, most negative, that's correct, that's where this orange wire is going. I'll just angle that around so that it's roughly right for my, mustn't short these two together because they're 12 volts apart, 12 volts and lots of current. So I'm not going to have it taut, I'm going to push it back a centimetre and then cut it, tin it, solder it onto there, try and get a piece of heat shrink on there, see how that goes. Yeah, it's worth doing this mining. I've done $2.36 today. How are we looking on the export? Yeah, we've got 77 watts going to the pylon, so 77 watts of export. It's a beautifully clear blue sky out there today, so I'm switching on as many power banks to charge as I can. 4 miners going, so I'm using up almost all of the solar power coming off the roof. That's what you want to do. You want to make best use of it. Okay, let's tin that. That's good. I'll tin, that's a bit mucky on there, but I'll just tin that. And I've put a tiny piece of heat shrink on there. So that all looks pretty good. Let's bend that over onto there and solder it on. Yeah, there's a little bit of jaggy on there, but I'll see if I can get the heat shrink round now and get it shrunk. Now I can't use the deflector on my heat gun, so I'm going to have to use the director. See if that will shrink up. Well, I've got to remember that's metal as well. Oh, this is no good. 416 watts of grid electricity being used. Right, stick that there. Press that switch if I can get to it. Turn the miner off because that's... I mean, a cloud has just gone in front of the sun. It's only a wispy cloud, so it'll be gone soon, but I will shut that off. Come on, sun, come back to grid export. So the next wire is this white one. Tack those together and see if I can pull it through. I've got to try and make it not tangle up with all of this lot. Right, let's solder the white one onto the battery midpoint. I think that's right. Slide that over and heat shrink that. Now on the other side I've managed to pull the yellow and red wires through, so I will do the same thing with these. Get them taut, push them back a centimetre, chop them. Yes, I can chop them both together, can't I, because they're not connected to anything. Solder them onto the little tags, put some heat shrink on. Yeah, they look okay. And well, that will be enough that I can put my little tester on this thing and the balancer, and I will have something to play with for a day or two. So let's get that finished and I'll play. Just heat shrink those, being careful not to short the two bus bars together. Oh, the yellow one's a bit gone out of position, so I'll do the red one, come back to the yellow one. Let's just reposition yellow, it's got caught behind red. Right, that's yellow and red going through their little holes. On the other side we've got three, because we've got white, black and orange. And I've checked the sequence and I'm fairly happy that it's all good. So I should now be able to connect my little checker and have a look at voltages. So as before, orange is the most negative, not black. Mustn't get confused. Plug that in. Oh, and I resoldered where the 9 pins are along here, where they went into the PCB inside this unit. Didn't look like it was very well soldered, so I resoldered it because I was having those problems with one of the cells looking low, but that's now looking pretty good. 3.34, 3.35 across the board. That says it's a 0% because it's probably on LiPo. So I'll set that to, oops, missed it, live fee, save, and now it's saying that it's 80% because it knows that it's a lithium iron phosphate. 3.34, lowest is 3.34. That's quite hard to read, but they're all 3.34 or 3.35, and in bigger writing, that one. And now the sun is streaming across my desk and we won't be able to see this little display, but anyway, you've seen it. So I think I'll call it there. That's the end of this video, but I will carry on. I've got to do the same thing again on the other pack. I've got to make a choice. Do I go for 5-way connector on the other pack? There's the nice big writing. Oh, it's difficult to see, isn't it? Or do I go for a 4-way? There are reasons for doing both, but anyway, I'll come back to that in another video, so cheerio.